So this is what a Karnaugh map looks like with 3 variables. And let's go ahead and map this. So here we have an input-output table with 3 variables, and we can map that directly to the Karnaugh map. Now notice the order. So here we have YZ if we look at the table, it goes 0, 0, 0, 1, 1, 0, 1, 1. And that's the order that we're used to seeing Y and Z go in. If we look here, it's 0, 0, 0, 1, 1, 1, 1, 0. And this is the way that they change 1 digit at a time, right? Because we go from 0, 1, we just add that 1, we go back to 0. This is a big deal. It's important. If you don't set the Karnaugh map up like this, the results will be incorrect. So it's really important that this labeling works like this. When you get to 4, the same order applies to down the left side too. So really important to get right order on here. So pay attention to that. The next thing that we're going to do is we're going to just be working with 1s. So we know we're not doing anything with the 0s, so I'm not even going to fill them in. I'm just going to fill in the 1s because that's what we're looking to group. So the very first one here is where X is 0 and Y and Z are 1. So here's where X is 0 and here's where Y and Z are 1. So that's where I'm going to put that 1. The next one in the table is where X is 1 and Y is 0 and Z is 1. So there's X is 1 all along here, and then Y is 0 on these 2, and Z is 1 on this one. So it's right here where this one goes. The next one is where all of them are 1. So here's where X is 1 and here's where Y and Z are 1. So the third one goes there. So the 3 1s that are in the input-output table are now in the Karnaugh map. So we mapped them directly. Now they represent the same thing. The next step is to group in powers of 2, and we want to make the groups as large as possible. So we certainly have groups of 1, but that's not the largest. Can we get groups of 2? We can get groups of 2. Can we get groups of 4? We can't get groups of 4. And a group of 3 isn't allowed, right? So let's go ahead and aim for our groups of 2, and let's see if we can find some. There's a group of 2, right? They're adjacent to each other. And there's another group of 2. Now notice when we do these groups of 2, they overlap. So here, this one is in both groups, and that's fine. You want to make the groups as large as possible, even if they overlap. So we have 2 groups of 2, and the next step is we want to write the terms for each group, okay, as an expression of the variables that do not change. So let's look at how that is. So I've written them here, and let's see if we can understand how that works. So if we look at the first one, this group that's upright, the X is 0 in this box and the X is 1 in this box. So the X is changing. So we won't use that. But the Y is a 1 and the Z is a 1 in the entire group. So those are the ones we're going to use. And since they're 1s, we'll use the variable itself. So we have YZ. Now the other group, notice that X stays the same because it's 1 in both elements in this group. So we'll use the X. There you see the X. And the Y changes. In the first one, it's a 0. In the second one, it's a 1. So we're not going to use the Y. The Z is the same. It's a 1 in both cases. So we're going to use Z. And that's how we got those 2, that they don't change. So our terms are YZ for this one group, and the other term is XZ for this group. And then we just put them together with an addition, right? So for each group, we actually use multiplication to put them together, and then between the groups, we use an plus operation. Now, if we compare that, this was what we got with the Karnaugh map. If we compare that with what we would have got with the sum of terms, we can see that is significantly more simple with the Karnaugh map. Now, it is possible that you could use Boolean algebra to get this down to here. It's also very likely that using Boolean algebra would simplify into a different expression. They don't always map to exactly the same expression. And Karnaugh maps aren't always the simplest form, but they get it significantly more simple. And so it's a way to get directly to that more simple version.